Good afternoon, friends, and welcome to the presentation on machine learning. My name is Parin Patel, and I am a graduate student at Texas A&M University, Kingsville, majoring in computer science. Now, what is machine learning? Machine learning is an artificial intelligence that provides computers with ability to learn without being explicitly programmed. Machine learning focuses on development of computer programs that can teach themselves to grow and when they exposed to new data. And intelligence requires knowledge. It is necessary for computers to acquire a knowledge. So basically, a machine learning is like learning the computers by own. They grow by themselves when exposed to the new data. So basically, machine learning is like automating automations. So it goes on its own, so like getting the computers to program themselves. So it is designed in such a way that they can program themselves and work on it and let the data to work instead of in, let the data to do the work instead. So like the data is going to help you out, helps machine learning out to do to get the results. Now what do we expect with machine learning over the traditional programming? So here's the thing, like in traditional programming, we input the data as well as program to the computer, and what we get is output. In machine learning, it's the reverse. So in machine learning, we input the data, and the output we got it, we computed it manually or some other ways out. We give it to the as a computer to the computer, and what we get is a program. This programs helps to generate more data, and after generating more data, we need to compare with the results we actually got. So this is how machine learning works. To simply understand machine learning, it's similar to a gardening. So what do we do in gardening? So like we have seeds, we have nutrients, we have gardeners, we have plants. So for a machine learning, seeds we use to gardening are called are similar to the algorithms. Nutrients can be are similar to data, whereas gardener is the you, the analyst, and the plans is a real program which computes the things. Here are some applications of machine learning. The first one is we have web search, we have spam folders, e-commerce, robotics, information exchange, and social networks. So whatever you search on like Google, it's a part of machine learning. It learns from the results you got it, and like that. A spam folder, like in a usual email, you have a spam folder, right? So every incoming email is classified into a spam or not spam. Then it goes to your mailbox. For like in social networks like in Facebook, we have news feeds, right? So these news feeds are a part of machine learning. It grows from your previous searches and everything. Machine learning in all, there are like thousands of machine learning algorithms, and hundreds grow every year. Hundreds are developed every year. But there is one thing common in every machine learning. There are three components that needs to be in a machine learning algorithm. They are representation, evaluation, and optimization. So what is representation? It is important that classifiers are written in a language which computer systems can understand. It is very important that the classifiers which are written needs to be in a language which can computer systems can understand. It is equally important for classifiers to keep on learning and updating with the new terms and definitions. Conversely, if a classifier is not in the hypothesis phase, it cannot be learned. So in general, representation consists of decision trees set of rules, that is logic programs, sorry, instances, graphical models, and support vector machines. The graphical models are Bayes and Morex. Evaluation. To classify in between good classifiers and bad classifiers, we need a function to distinguish it. So this is objective functions or scoring functions. We need to keep in mind which classifying algorithm is used internally and algorithm used externally may differ. Evaluation consists of accuracy, precision, and recall, squared error, likelihood, post-rate probabilities, costs, margins, entropy, KL divergence, etc. Another part of an algorithm is optimization. This is the last part. It keeps up learners' efficiency and helps the classifier produce if the evaluation function must choose among more than one optimum. Finally, it searches for the highest score ones. Combinatorial optimization, convex optimization, and constrained optimization. Now let's understand the concept of generalization. So basically, let's see here. So this is an apple, this is a cow, and a horse. So these are the versions of apples, these are versions of cows, like all different types of cows, and these are all different types of horses can be possible for a classifier. So if we need to generate a test set, we need to generate a test set from all the raw data so that we can test our classifiers to check on if it is working properly or not. So let's see here. So this is one type of apple, this is one type of cow, and this is one type of horse. They are derived from a training set and are called test sets. It is very important to not feed the classifier all the test data, so that we need to keep some of the data with us and not feed all of them to the test set, so that we can at the end of the generating the algorithm we can test on are the separated data which we kept aside and see the results and compare the results with it to get it done. Spectrum of supervision. So basically we have divided the spectrum of supervision into three types: unsupervised, weakly supervised, and fully supervised. So from the figure or from the images itself, let's say here, this person is behind his car. So it is very difficult to identify for a machine, I mean for a program, that what is this image about? Is it about the person? Is it about the car? Let's say here. Let's say here there are too many cars, and like some are the new cars, some of the old cars, so it is very hard to define what is the image about. In this one, a lady is with his pet, and it's difficult for a machine to determine, is it about her, is it about her pet, and so on. So these are the weakly supervised, like this is a person standing behind a shell, so we can easily identify the person, but it's very hard that it is regarding to the self or it is just a profile. And let's say here, a fully supervised. So let's say this is a car. So we can easily figure it out. There is nothing focus other than there is nothing other than the car. So we can easily focus. I mean, the program can easily focus and say that this is a car. This is a person, easily, which has two eyes, one nose, one mouth, and so on. So in the image, it is from less to more supervisions, like so on. Now let's see how many types of machine learning is possible. So we have supervised learning, which is also called inductive learning, in which training data includes desired output, and unsupervised learning, in which training data does not include desired output. Semi-supervised learning, in which training data includes a few desired outputs, and reinforcement learning, rewards from sequence of actions. It's like a loop. Inductive learning, which is also called supervised learning, it's a given example of a function where x is a function of f of x, and there's a predicate function f of x for new examples x. Discrete f of x is a classification. Continuous f of x is a regression. F of x is equal to probability x and probability estimation. A supervised learning is of decision tree induction, rule induction, instant-based learning, Bayesian learning, neural networks, supports vector machines, model assemblies, and learning theories. And in unsupervised learning, there is a clustering and dimensionality reductions, etc. Machine learning in practice. So, understanding the domain and prior knowledge and goals. Data integration, selection, cleaning, and pre-processing. Learning models, interpreting results, consolidating and deploying discovered knowledge, and it's in the loop. With this, our presentation has come to an end. I know this machine learning is a very vast topic and it covers a lot of concepts, a lot of algorithms, classifiers, and stuff like that. And the best part of it is we're gonna be seeing the machine learning on a very large scale in near future. It's gonna be using a lot. We will be using a lot in our day-to-day life. It is still be in the growing process, so it will take time. It, but I'm pretty much sure it won't take much of it, and we'll be seeing it soon. Rest is like thank you, and I hope you enjoyed my presentation. Bye for now. Thank you.